All right, let's look at the undefined terms for this class. All right, so undefined terms for this class would be points. All right, points and the line, also plane and space. All right, so those are the undefined terms. And also, we like to talk about the notation we use for this class. It's basically, as we're going to use a set notation. So we can think of space as the universal set, which contains all possible points. So we're going to use S for that. So S stands for space. All right, maybe I'll make it fat so that here. So S stands for space, and this is just universal set. Oops. And for lines, we're going to use a lowercase letter, especially L, M, and N. And if we need to talk about a lot of lines, we probably start using L1, L2, and so on, using subscripts, right? And the planes, we're going to use kind of a fat P. So we have a P. And if we have a lot of planes, we can use probably P1 and plane to P2 and so on, again using subscripts. And a point, we're going to use the uppercase letter, so point A, point B, and point C, and so on. All right, so we're going to use basically a set notation. Hopefully everyone's familiar with the set notation. And here are some examples. Let's say if you want to say something like, line L meets plane P, say at point A, right? In set notation, you can say, right, so L and the intersection of L and plane P is going to be a single point A, right? So this is a set notation meaning the same thing. And also, let's say something like if the line is lying on the plane P, so line L lies on the plane P, right? And we can use a set notation, so we can say L is a subset of the plane P, right? And the last one, we can say line L is parallel to plane P, right? We can say that the intersection of the line L and plane P is going to be an empty set, right? So you can see that we have a nice and compact notation for each of these situations using the set notation. So we try to use set notation as much as possible. Right? That's it. I hope that this was clear.